Hello, everyone. Welcome to FHE On Chain podcast. Today, I'm having Kurt from Duality Technologies. I'm Furkan from Inco. I'm working as a researcher and technical writer there. Today, we will talk about FHE and some other PET technologies, and of course, what Duality does and what Duality's vision is today. So, welcome, Kurt, and thank you so much for being with me today.
Sure. No, thank you, Furkan. Happy to be here and happy to talk about FHE and kind of broader applications of the technology.
Yeah, thank you. I would love to start with your background, who you are, and what kind of, not only educational, but also both academic and institutional background you have, and your journey till today.
Sure thing. Um, by training, I'm an engineer. So I got a bachelor's, master's, PhD, all in electrical engineering. I happen to be of the generation that went into defense industry a little bit after the 9/11 attacks here in the US. So I started as a defense contractor working for a company that at the time was known as BBN Technologies, where I got to know a lot of the early founders of the internet, because a lot of the early ARPANET was work used to be done there. So I happen to be very, very fortunate to have known, for example, the gentleman who invented email and kind of similar technologies in the early foundational internet. But earlier in my career, I was, kind of a very fortunate position to do a lot of work in support of DARPA, which is the blue sky R&D wing of the U.S. government, and all kinds of really enjoyable, kind of impactful projects for secure compute and big data systems and data modeling and things like that. And I happened to be at the right place at the right time to run one of the first implementation teams for technology now known as fully homomorphic encryption. And so I got involved very early on back in 2010 with one of these very seminal programs where it was a bit of a who's who of Craig Gentry and Shai Halevi and Shafi Goldwasser and Vodun Vakanathan and Yali Michancio and kind of like a little bit of everyone was involved. And I really drank the Kool-Aid on this tech. I thought it was going to be a big new thing. And so I very soon after resigned my position at the company, um, and with the intention of founding this company that's now called Duality Technologies, and spent a few years in academia with support from DARPA, building up an open source library for fully homomorphic encryption. What at the time was called Palisade, is now called OpenFHE. And with Shafi, Vinod, and some of my other co-founders, Rena Shansky and Alon Kaufman, we created Duality to take these technologies and commercialize them, initially for the Web 2 space, primarily in regulated data industries like healthcare and financial services. But through it all, we've been very focused on how do we enable secure data collaboration with a highly secure privacy technologies, such as fully homomorphic encryption. And so while we've been pushing forward Duality as a commercial product, software product company, we've also been rather bullish on open source implementations of privacy technologies. And I've been working with my longtime research partners, such as Yuri Polyakov and Dave Cousins and a few others, building out OpenFHE. And we're very happy to see how this community around the technology has blossomed and grown and been starting to get uptake in the Web3 community also. So that's a high level overview, but back to you.
Yeah, it was great. So yeah, like obviously the next question was about duality. Like, I mean, it's really impressive to see like like yourself, like Shafi Goldwasser, and more great people in the team. So and like, I mean, I'm familiar with duality for a long time, but like I mean, although I'm always getting impressed when I click on the web page and see dozens of different things in the resources part, in the like the documentation part. So how would you describe duality? Like, I mean, what is duality exactly? Because there are lots of works, lots of implementations, lots of research papers. Of course, the main, like, the main idea is like the privacy, or like privacy enhancing technologies, but I'm seeing there almost all the use cases of privacy enhancing technology. So in a couple of, maybe not a couple of sentences, but like, I mean, in a concise way, how would you describe duality?
No, it's a great question. Happy to answer it. So, Duality inherently, we're a classic venture-backed software product startup, meaning that we take investment and we build software product, and we sell software primarily to enable secure collaboration on sensitive data. And so, sensitive data could be anywhere from banks sharing financial records to fight fraud and other kinds of financial crimes like money laundering and things like that. We sell software to medical research centers so that, for example, cancer researchers can share data and develop more effective treatments for rare diseases with greater efficiency. And so this is because we're using privacy, our users can use privacy technologies. There's less need for things like data use agreements and MOUs and even easier IRB approvals and things like that. And so inherently, we're a software product company, as I said. But we're very proud to be on the cutting edge of what we do. And under me as CTO, we also run a very healthy business around contract R&D. And so this is, for example, work we do for places like DARPA or ARPA-H and kind of related organizations, in addition to consulting with private companies on development of advanced capabilities for homomorphic encryption and advanced applications of homomorphic encryption, particularly built around our OpenFHE, open source fully homomorphic encryption library. So it's a very active side mission that we do, but of course, like I said, our main focus is in product. And given that we're very early to the market overall, we do engage a lot with public advocacy for privacy technologies. So I spent a lot of time working with policy experts in DC and other capitals, um, trying to educate on the value of privacy technologies for efficiency of research funding, for the ability to kind of protect citizens' interests and furtherance of protection from financial crime. And we also, as a side channel to that too, we also do a lot of work engaging with standards bodies like NIST and ISO to advocate for the adoption, both the formulation and adoption of standards to help interoperability of secure data systems also. So there's a lot that we do, but like I said, bringing it all back, we are at our core a software product company primarily for Web 2 and kind of related applications. So.
Thank you. Yeah, like, I mean, you've been working with FHE like for 15 years, like till, I mean, since 2010, which is quite early. Like, I mean, when we take the milestone in 29 with Gentry's paper. So like, so I think you're the right person to ask like about the history of FHE commercialization, because I mean, obviously, like, I've been in the FHE space like for like 1.5, maybe 2 years, so quite early. And what I know about the history is like, the papers and like the chronological order of the papers. But like, as a person living the entire journey, I mean, how it looks to you, the history of FHU commercialization, because as far as I know, it's been not easy to actually implement and use it, in a daily use case, right? So it would be great to get some insights on that.
Sure. No, that's a great question. And one thing I can't overstate enough is the kind of the very generous and very seminal investment that DARPA has made in the technology also. Craig Gentry did excellent work on his PhD thesis publishing this, particularly when he was an intern at IBM, working on his PhD with Dan Bonet at Stanford. But when his paper came out, it really got the attention of several colleagues at DARPA who saw the value of this technology. And the vision originally was to securely enable cloud computing. Way back in 2010, when this was being discussed, cloud computing was still relatively new. It was actually a bit of a scare a lot of people had about do we really want to take our secure data and put it on a commercial cloud? Can we really trust it over there? Like, who's going to have access to these things? Who's going to be able to log in, especially if you have data shared on devices with folks you don't necessarily trust? And so FHE was seen as a way of doing that. And there, particularly at DARPA, there was an individual by the name of Drew Dean, who was formerly at SRI, but spent several years at DARPA, who was a really true visionary and one of the best PMs I've ever worked with at DARPA. And he had this vision of when new encryption technologies are discovered, it generally takes 20 years to commercialize them. So, for example, you look at RSA. Depending on who you ask, RSA was discovered by the RSA authors in the mid 70s, and RSA started to become publicly used, give or take mid 90s. Public key cryptography for the internet and the internet shopping. You look at elliptic curve. Elliptic curve cryptography was invented roughly mid 80s, give or take. And when was it first commercially used? Well, Blu-ray players, in the mid 2000s overall. And so again, 20 years. And so Drew had this thesis that it would take 20 years to on their normal course of things for FHE to become real and practical for real world use. And so he said, if DARPA can make an early investment in this technology, we want to accelerate this. We want to take several years off that 20-year timeline. And so he did an excellent job, putting together this really kind of top tier, ensemble of researchers. And I was just very, very fortunate to have been in the right place at the right time to run the implementation team. And we were doing just absolutely wonderful things. A lot of the early protocols, like BGV, BFE, variants of like CKKS came out of this seminal program way back when, and performers on the seminal program, and it really is a bit of a who's who. There's been subsequent kind of follow on from that. At the time there was a kind of a parallel effort being done at Microsoft Research with Kim Lina and Kristen Lauder, who were on doing their own thing, but also on the periphery. And a few years later, there was an EU HEAT project that did kind of some similar things, also, semi-related, but also on the periphery, in addition to kind of a few things at places like Japan and South Korea. But so it is, and I was really bullish on the commercial application of FHE tech, but I also saw the need for kind of early standards around this too. And Kristen, who I alluded to, who was at the time running cryptography research at Microsoft, was had the foresight to put together an early workshop at Microsoft Research in Redmond. I want to say roughly 2018, 2017, give or take. I'll get the exact date a little bit off. And again, kind of convened a lot of the kind of main people in the space, including NIST and IETF and ISO and a few other domains, to start thinking about standards. And so we started having this regular kind of community set of meetings called the Homomorphic Encryption.org standards meetings, where we would go and kind of put together, position papers as a community effort, and was always a community effort about what are secure, secure settings, what are secure protocols. And on purpose, we always invited representatives from ISO and IETF and NIST and a few others. And you see a lot of great work for this going on. And ISO is on the cusp of releasing a finalized standard for homomorphic encryption that is direct outcome of these kinds of community efforts and things like that. And it's these kinds of efforts where the technology development, the papers are great and the open source implementations are great, but it also takes a lot of these kinds of community activities on the side to make it real. And the nature of secure collaboration technologies is driven fundamentally by trust, and trust is driven by community engagement, and community engagement is driven by not just standards and not just government policy positions, but also open source and transparency. And this has kind of been another major thread of the community history, is that it's always been fundamentally open source first. And so we even see like the very, 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 very first implementation from Craig and Shai Halevi at IBM was open source, and a lot of the work that we've been doing the whole way through on Palisade OpenFHE has always been open source. And there's been a few kind of pushes back and forth on various kinds of licensing models and things like that. But really, open source has led the way because of trust and community as it is, and adoption and building community too, which I'm very happy about, very proud of the work that we're doing in terms of just developing open source community in addition to standards community too, as it is. So I know that's a little bit of a kind of a laser view of it, but there's a lot of things going on, and I can't get enough credit to the entire community too.
No, no, that was great. I mean, I could listen to it for hours. So like one thing like took my attention quite more, like DARPA, like the effect of DARPA on this history. So why is FHE interesting to DARPA actually?
Sure. So a few reasons. DARPA has a very interesting, a very important mission, I think, in the world, and that is to really, uh, they say two sides of the coin. One is to prevent surprise and create surprise at the same time. And the kind of preventing surprise is, are there adversaries, folks who really want to do harm to broader society? Are they going to invent some new technology to go do that? And DARPA's mission partially is to go and explore technologies that adversaries might use, cyber criminals and things like that. On the other side, creating surprise is developing new technologies to protect the U.S. and Western-oriented democratic allies, of course, also. Um, and there's a few features of FHE that seems to have resonated with the DoD community, and that's partially it's quantum secure, meaning post-quantum, resistant to quantum computing attacks. Partially, it basically provides a really nice method for software protection of kind of software protection of data confidentiality. And so you might need to run and use hardware that might be coming from an untrusted source. Can you provide a software patch to kind of run on top of less trusted hardware that gives you a high degree of data confidentiality? And homomorphic encryption does that quite well, in that you can decrypt data and deploy it and get very strong guarantees about the confidentiality of the data also. And then there's also aspects of how it kind of fits in and kind of plugs in into like a lot of legacy environments. And generally folks who have a lot of data tend to be large enterprise organizations, which means they have existing protocols, existing ways of working, existing ways of doing these kinds of things. It wouldn't it be nice that if you could basically push out software updates and software patches, which are much, much less expensive, much easier to do than updating hardware also. And so this is a really nice thing in terms of protecting against cyber theft, cyber criminals, bad cyber actors as they are. And so this is a core part of the DARPA mission also is just protection for cybersecurity too. And so DARPA has been through subsequent generations of various PMs has been very generous in their support of FHE and as it relates to kind of this broader mission of protection against cyber criminals also. So thank you.
So like so it's not only World War II. Like I mean, it's always a defensive industry is actually a strong partner in cryptography and its development.
Yes, it is. I would say not just, I wouldn't necessarily frame it as cryptography. Is that, DARPA is always been a force for cybersecurity in terms of protecting data, protecting, critical systems, and as it is. And, FHE is, yeah, it's a cryptography. It came out of cryptography. I see it as a data collaboration tool and as a way of kind of, protecting privacy and things like that. I think to call it cryptography does capture a kind of a core essence of it, but I think it kind of misses kind of the bigger picture of what fully homomorphic encryption is, which is protection for data in use, which is, goes beyond kind of the core of what people think of as cryptography also.
I like that. So let's get back to OpenFHE. Like
Sure.
there are many implementations. Some of them are open source, some of them are maybe not. There are some small implementations, like I mean, in the like individual works. I mean, even I did implement BFE once, but like I mean, there some of them are big enough to be used in like in real apps or like in future apps. So here, how do you see the the place of OpenFHE compared to other implementations?
Sure thing. No, that's a great question. What we've tried to do generally at OpenFHE was to create a very inclusive library that's easy to use with very generous licensing terms also, so that anyone can use it. And I'm aware that several of Duality's competitors use the library, which I'm just perfectly happy about. For one, it shows that it's a trusted library, and for another, when we get into competitive situations, we love to kind of point that, like, hey, do you want to use someone who's using our library? You don't want to use our library, kind of the situation. Um, and inherently, OpenFHE was developed at different times for different reasons. Very, very, very early on, it was developed really more of a proof of concept to show that FHE could exist. And this was kind of back in the upper Proceed days and things like that. As we kind of progressed and started looking at kind of subsequent programs and subsequent projects, we saw the need for you know common implementations of a lot of the same cryptographic primitives, for ring learning with errors and things like that. And so originally we built, the library that is now called OpenFHE to provide a set of primitives for, vector addition, vector multiplication, vector convolution, things that you kind of need for ring learning with errors type cryptographic library as a kind of a rapid prototyping environment for FHE research and kind of related uh, lattice crypto research too. As we were building up, we saw it more and more as an ability to rapidly deploy applications. And so we started basically providing various hardware backends and hardware interfaces for it. We also provided a lot of kind of higher level building blocks for people that want to run FHE applications on top of OpenFHE also, and supporting multiple protocols. And so we basically saw it as a bit of a Swiss Army knife for FHE, in that it does a lot of things quite well. Obviously there's need for specialized libraries for very specific things. You want to run a specific hardware and stuff like that. We get it, but we see as an OpenFHE is kind of an easy to use kind of general library. And I can't at all take even majority credit for it, let alone even part of it. All credit goes due to my longtime research partner Yuri Polyakov. A lot of work of other individuals like Dave Cousins and Jerry Ryan, Ahmad Al-Badwawi, Andre Alexandru, and many others contributed to the library too over the years, and partners and other contributors from other companies. This other thing I also want to say is I'm very happy with kind of other contributors that we've had to the libraries from places like Intel and Samsung and MIT and many other companies like CACI and Raytheon for that matter. So it has been a community effort. I'm very kind of proud to see how it's grown, and really want to encourage it and encourage community growth too as we go. So
Thank you so much. So like there are some use cases, like very well known use cases. I mean, maybe not very well known, but like very well known across FHE enthusiasts, let's say. One of them is obviously machine learning or artificial intelligence, whatever you wish to call it. So, how do you see like the both current efforts and the future of confidential ML leveraging FHE? And also, is there like are there any mistakes or some like missed points to be focused more to make it more effective or or efficient to achieve actually the confidential AI at the end?
sure thing. No, that's a great question, and this has always been the kind of thing that we circulate for in the FHE community. Obviously, as a lot of people know, that when you encrypt data and compute on data while it's encrypted, it's going to be slower. And sometimes that's used as a dismissive, like, oh, that FHE stuff, it's going to be slower. Why bother? What we see it for commercially is that if you want to compute on very sensitive data, the current best methods for protection, or the kind of, I wouldn't say best, but I would say that the kind of legacy methods of protection are legal agreements. And so you got to hire very expensive lawyers. So you got to spend a lot of time writing MOUs and NDAs in order to share data. And that might be fine if you're a large, well-resourced organization like the US government or Harvard Medical School or things like that. Uh, but what if you're kind of at a smaller university? What if you don't necessarily have easy access to lawyers? How can you help push forward data collaboration? And lawyers take time and they're expensive. And we see the value of FHE is basically moving things that are a very kind of slow human driven process and then moving it into a place where it's increasingly automated. And so something that would take days, weeks, months because of lawyer time might move into seconds or minutes with FHE protection also. And so we see this as kind of like the major value add of the technology. But you do bring up ML and AI and whatnot. A really nice application that we're seeing is, fine tuning of machine learning models. And so you have, for example, open machine learning models that you might download over the open internet, but they might work for like image classification and stuff like this. Well, wouldn't it be great if you could take these commercial models and fine tune them for imagery data or other kinds of classifiers that you have that are maybe running on sensitive data. And so we see this fine tuning techniques as a major advance where you could basically use FHE to retrain or fine tune a commercial model very efficiently. Particularly, whether it's something using techniques like fine tuning the last layer of a neural network, based on specialized data. So you get these kind of higher performance type capabilities where you have the best of both worlds. Basically a very good model, retrained and tuned specifically on sensitive data also. And so this is a big thing that we're tracking also. So
Yeah, yeah, super exciting. And the other, which I'm personally quite bullish on and excited on, is confidential healthcare. Because like there are obviously many different subfields of this, like confidential genomics, confidential, you know, like cardiovascular disease risk analysis, or anything about health. Because like I mean, when you consider the generic data, apart from any specific focus, some data really need not to be encrypted. But in healthcare, everything should be encrypted. This is for sure, because like I mean, this is super confidential. So, and I do know that Duality is doing around confidential healthcare, and I would love to hear what they are and what is your personal opinion on this.
sure, no, that's a great question, and you're right. This data is very sensitive too, and there's kind of like one of the challenges with healthcare data is that the kind of the I would say that the threat model, the regulatory model is a little bit different overall. Um, One of the challenges with healthcare data is that diseases do not respect national or international boundaries. And so there's this need for, basically international collaboration on sensitive data. There's this kind of very pernicious problem that we've been tracking at Duality, which is, what was generally called rare disease analytics. And so the challenge with rare disease is that they affect, and I'm going to get the definition a little bit wrong, but a rare disease is something that affects one person in 10,000. Okay, give or take. Bear with me. Um, and the challenge with rare diseases is that if you look over the entire population of the world, however many billions of people, a significant percentage, something like 20% of the world population, is going to be impacted by a rare disease at some time in their life. The trouble with this is that any one rare disease is going to, any one doctor is going to see any one rare disease once in their entire career. So it's very hard for clinicians to develop effective treatment if no one has enough visibility on patients that have these
Yeah.
kinds of things. So you start to basically have this need, whether it's for general society like an NHS or NIH, being able to combine data across geographies, let alone across states here in the United States or across countries, to develop and even understand, what are the kind of the driving reasons for rare disease progression. And it's a wonderful example of how there could be protected international collaboration um, that respects local, but not just privacy, but local regulations. And so, wouldn't it be great if, for example, U.S. and Canada and Europe and Turkey and kind of the rest of, the modern world could get together, share their patients' data, and develop centers of excellence for specific classes of rare diseases, while also respecting, data sovereignty and the rights of citizens and the rights of citizens' data, and how that's very different in various different countries, for example.
Yeah, yeah. I mean, I totally agree. Um, I have a question where we can separate it into two. Like, I mean, how do you think the adoption of FHE will play out over the next, let's say 5 years, in Web3 and Web2? I mean, I don't know how you are familiar with Web3, but I'm sure you are a bit. So it would be good, because like you've been here like for 15 years, so like I mean, knowing about the history would definitely enhance the vision of the vision for the future. So I'm quite curious about your your take on this.
Sure. No, that's a great question. I am less of an expert on Web3, and I've been putting a fair bit of time to try to understand it better for what it is. And one of the things that's kind of fascinated by Web3 is this boundaryless notion of compute. And so the notion of uploading data in the Web3 domain, and it gets very, you know, I would say in good and bad ways, fuzzy, where, what law might actually, or what kind of data regulation might apply in different domains. Which is great for financial applications in particular. We want to start doing things like moving value across different boundaries, and for particularly for particularly legitimate reasons, of course. Um, and so that's been an absolutely wonderful thing coming out of the Web3 space. One thing I see a value for it is particularly when it comes to transactional type behaviors in the Web3 domain, and what does that mean? And particularly having things like AI agents go and propagate various kinds of trading actions or kind of interactive actions in the Web3 domain, particularly where you don't necessarily want to reveal trading strategies or things like that is a big thing. Or things like risk analytics. I suppose you want to engage in a transaction, engage in a loan, something kind of like that. Uh, can you start perform risk analytics in a privacy sensitive manner also? And so these are kinds of things that I'm tracking, whether they're feasible or not in the current Web3. I would welcome education on that, of course, also. Uh, in the more traditional Web2 space, I'm very bullish in healthcare. There's been some really nice policy positions coming out from US government and UK government about privacy technologies writ large being acceptable to use to protect medical data in general. And I think this is going to be a bit of a watershed moment over the next few months about the increasing use of privacy technologies, particularly in the health domain and Web2 space. So I see it in its two sides. The first users are always going to be in what we would call the regulated data environments, finance, healthcare, government, things like that. Web3, I see it potentially a little bit more on the financial side, and Web2 a little bit more on the healthcare side as it is.
So what do you think? Like, let's say 5 years later, like what's gonna be the status of like FHE? Not only in terms of benchmark, but also the adoption of it into the existing traditional technology.
Sure. So one thing that I learned from a few years of doing DARPA work is that if you would develop an advanced technology, the best way to get it used is to make it, in this tongue in cheek, make it as boring as possible. And what that basically means is make the technology usable in current workflows so that the users don't have to change what they're doing at all. And so, for example, in kind of like a kind of a core military domain, if you have a soldier, don't have the soldier need to retrain, to use a new technology. Um, in the data space and data analytics space, the core for that is, hey, folks are already using data science libraries like in Python, like the NumPy, SciPy, scikit-learn. There's plenty of statistical libraries in R, and so I see kind of like the big watershed moment is improving programmability and usability of FHE primitives by exposing them as existing known data science frameworks. And so basically make the technology, so to speak, boring, that you don't have to necessarily program it in a different way. And I've seen a number of advances that I'm really excited by. Yuri Polyakov and Andrei Kim and Andrei Alexandru had this recent result on programmable bootstrapping, particularly for CKS, which is, I think, really going to enable a lot of kind of general floating point and fixed point type computations. And there's been a number of activities on compilers and other kinds of integrations of data science libraries that I'm very excited by. And so I think
Um,
this is kind of like going to be the next big thing, in my opinion.
So, like for those who are curious, let me mention the name of the paper. It's General Functional Bootstrapping using CKKS by Yuri Polyakov, Andrei Kim, and Andrei Alexandru, I believe.
Yes, it is.
Yeah,
Yeah. Yep.
yeah. So yeah. People, if anyone is curious, then they can go and visit the paper. Yeah, we have a one final and quite fun question for our guests. Is there any sort of favorite book that you can recommend to our listeners? Like it could be technical, it could be non-technical. Um,
Sure. So there's a book that I read when I was a PhD student that really kind of changed my opinion about the nature of science and innovation. And it's a novel by a gentleman by the name of Sinclair Lewis called Aerosmith. If you're not familiar with Sinclair Lewis, he was the first American to ever win the Nobel Prize for Literature, and he's probably
wow,
one of the best writers that's least well known, for what it is.
wow,
And so he wrote back during the turn of between the 19th to the 20th century, and he wrote in a number of books about kind of different aspects of American life. But this book, Aerosmith, was about the nature of research, what it means to be a researcher, what it means to be a researcher in the context of a broader society, and responsibilities that researchers have as they are. So yeah, I read this book when I was in my early 20s, and it really changed my mind in terms of thinking about what it means to kind of bring innovation out into the world and the kind of innovation one should be chasing. Also, can't recommend it enough, and it's completely unknown compared to the importance of this actual author for who he is.
yeah. Excellent timing for me. I'm 25, so I need to read it now, like in my mid 20s. So thank you so much. Do you have any final words that you want to talk about before closing?
No, thank you for your questions. I've enjoyed the conversation. I have a lot of respect for what's been going on in the Web3 space, particularly the work that's being done by you and your colleagues at INCO. I think it's really great work. I'm still trying to understand kind of the broader implications of Web3 on society, and following both INCO's work and the broader Web3 domain has been fascinating for me. And so, thank you for that also.
Thank you so much for both your kind words and also being with me today. Thank you so much. So, thanks everyone for tuning in and listening this episode with Kurt and myself. We talked about duality, like FHE's history, and the Open FHE library, and many things more regarding the use cases and FHE adoption. See you in the next episode. Thank you so much.